Question 5, Part A. The structure of ester V is shown. So V is this. So this is the ester bond. Okay, name the V. So here we know that is propyl. CH3, CH2, CH2. Propyl bonded to this oxygen. So the name is propyl. Here got 2 carbon, 1, 2 carbon. So propyl ethanoate. Okay, this is easy. We reacts with a reagent to form a salt of carboxylic acid, a salt, and alcohol. Identify a reagent that could be used in this reaction. So we must use sodium hydroxide. Why? Okay, because of this. If ester undergo a hydrolysis and under alkaline condition, after it's hydrolyzed, first, okay, the bond break is here. This oxygen will get H. This carbonyl carbon will get OH. So it will form carboxylic acid. And this carboxylic acid further reacts with the sodium hydroxide. Okay, and it will form this salt. So that's how to form this sodium ethanoate, this salt, right? So means we must use sodium hydroxide, because with sodium hydroxide, the carboxylic acid that form here can further react with it, form this salt. Okay, that's why here we need sodium hydroxide. Okay, draw the display formula for the alcohol made during this reaction. The alcohol made is this. Okay, this is the V, V. The alcohol that made is this one. Means this CH3, CH2, CH2OH. Okay, propane 1O. Okay, so display formula, so you just draw the display, show all the bondings. Okay, part 4. State one other possible use of V apart from food flavouring. Can use as a solvent or perfume. Okay, part B. Ester W make up of 54.5% of carbon, 9.1% of hydrogen, 36.4% of oxygen. Calculate the empirical formula. Okay, this one very easy. Use a percentage, okay, over the, assume is 100 gram. Okay, so use the 54.5 over the molar mass of the carbon. Okay, hydrogen is 9.1 over 1. Oxygen is 36.4 over 16. So at the end you get this ratio 2 to 4 to 1. Therefore, empirical formula for W is C2H4O. Okay, part 2. State what additional information required to determine the molecular formula. Empirical formula already here. In order to get molecular formula, we must use molar mass, relative molecular mass. Because with this molecular mass, we can find the multiplier. Okay, let's say N is the multiplier. O times the empirical formula, the mass, okay, equal to the molar mass of the compound. So we can get the N. Part C. X, Y, Z, okay, are shown. And they all have the same molecular formula. If you count that, you get C3H6O2. Okay, the X is actually ester, remember? This one, actually this is one hydrogens bonded, not shown. So this is ester group. Okay, compound Y is carboxylic acid, Z also ester. Okay, deduce molecular formula of XYZ. Okay, told you already, C3H6O2. Okay, just use one example here. Okay, C1, 2, 3 carbon. Hydrogen is 1, 2, 3, 4, 5, 6. Oxygen's 2. Okay, part 2. In 3 experiments, sodium added separate to the separate samples of X, Y, Z. Complete the table and give the observation. Okay, sodium with X. Okay, X is an ester, no change. Sodium with Y, Y is a carboxylic acid. Yeah, so there will be a bubbles form or effervescence. Okay, the sodium with Z. Okay, Z is ester, so no change here. Okay, part D. Sodium carbonate solutions react with methanoic acid. Okay, HCOOH. Write the equations for this reaction. Okay, so acid with carbonate forms salt, CO2 and water. Okay, remember the salt is the organic salt, so you must put the organic part in front and the sodium at the back. Right, so it's actually from this methanoic ion, right, with the sodium. Okay, that's all for this part, for this question. Thank you.